Hello, class. I'm going to give you a short lesson today on dealing with some more limits. So I'm going to quickly review the limits we've been doing thus far this year, and then talk a little bit about limits that deal with infinity as well. So up to this time, we've been dealing with limits that have a number answer, such as 3 or 4. And that's not always going to be the case when we deal with limits. But let's look at a problem like this one that we've seen. We have the limit as x approaches 3 from the left side of our function. We'll call it h of x. They decide to use h for the function here. Now, remember, this is just saying from the left side of 3, where is the y value going to? And remember, if you look right here, this says x approaches 3 from the left side. So we're dealing with x values, right? Here are the x values all across the x-axis. And we are getting closer and closer to x equals 3. So here I go, closer and closer to x equals 3. And the answer to our limit is going to be a y value or an output value. And in this case, it seems like it's going down towards negative 3. And so our answer will be negative 3. Now we could do the other one-sided limit. So let's just, for a second, look at that. The limit as x approaches 3 from the right side of the function h of x. Okay. Once again, they are saying x is approaching 3. Where is the y value going towards? Or where's the y value approaching? So go up here on the right side of 3, head towards 3, head towards 3, head towards 3. And the y value there seems to be getting closer to 1. Okay, so we did a lot of those one-sided limits, left-sided or right-sided limits. We also talked about two-sided limits. And so two-sided limits could have a numerical value, like our one-sided limits, but sometimes they also had, sometimes the answer to the two-sided limit does not exist. So let's look at just two quick examples of that. Let's say we're taking the limit of h of x as x approaches 3. And so this, because there's no plus or minus after it, we're going from both sides. And as we approach from both sides, one is negative 3, one of the answers. The other one is positive 1. Those are not the same. And so it might have said, hey, what does that limit equal? And we can say, oh, this actually does not exist. The one-sided limits are not the same. Okay, but we could get two-sided limits that do have an answer. So what about this one? The limit of the function h of x as x goes towards 0, or x approaches 0. What does that equal? So here we go. I'm going to do this in red. If it's a two-sided limit, we have to go towards x equals 0 from the left side and the right side. So we look, the left side seems to be going towards 4, and the right side seems to be going towards 4 as well. And so this answer would be, as the x gets closer to x equals 0, the y is getting closer to 4. All right, let's look at some to review, right? We used to, at the beginning of our graphical limits, have our x go towards a number, and our answer would be a number. Have our x go towards a number, and our answer would be a number. Those were one-sided limits. Then we did two-sided limits. Our x would go towards a number, and our answer was either does not exist, or when x went towards a number, our answer was a number. Examples here. Okay, this one, very similarly, let's try to approach negative 4 and do a couple limits with that. So let's take the limit as x approaches negative 4. Remember, the function is h of x again. There's h of x. So x is approaching negative 4 from the left side. And let's see what that equals. So from the left side, here's negative 4 right here. So from the smaller side, or the left side, where is it going towards? What y value are we going towards? We're going towards y is negative 5. Okay, it doesn't matter that there's an open circle there. It's still going towards y is negative 5. All right, and then let's check from the right side for a sec. So limit as x approaches negative 4 from the right side of the function h of x equals. And so as we go on the right side of negative 4 and we head up the graph, because we're trying to get closer to x equals negative 4. Remember, they're saying x is going towards negative 4 from the right. And it's saying, where are we going? Okay, and this is our first answer we're going to have that involves infinity. So it doesn't actually approach a specific number. It just continues growing without bound. So sometimes you hear without bound. Sometimes you see that we have a vertical asymptote there. We could answer this positive infinity or infinity, meaning that we don't have a specific limit to this, but we do know where the function's going. As we go towards negative 4 from the right side, it's going up, 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 farther and farther up. And infinity is not a number, right? It's not a specific number, right? It's very much a concept of, as we go towards negative 4, the y values keep on growing forever. Okay. Now, what we're learning today is that we can send our x towards a number and then get infinity for an answer, right? We don't have to just get a number for an answer. All right, you can see that. So quickly, we're going to talk about those two things here, which are, can we get some more infinities as our answers, meaning as our answer to the limit question. So here we go. What happens when x heads towards negative 2 from the left side of our function f? And if you look, as we try to go towards negative 2 here, this is going down, 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 down. And so we could say negative infinity, right? It's going down forever. But if I asked, what is the limit of the function f of x as x approaches negative 2 from the right side? Okay, let's go on the right side here. The right side, negative 2, we're going up, 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 up forever. Okay. So in those two cases, we see x is going towards a number, but the y value is growing without bound, or it's going up forever or down forever. So we get positive or negative infinity. Okay. There's one other type of question you'll see on today's homework, and that is, what happens if we want to see the end behavior of the graph? So the end behavior of the graph, we would say, what is the limit of the function as x approaches infinity? Meaning we want our x values to go towards infinity, and then we want to say, where is the y value actually going? So this changes the question a little bit. There is an infinity, but remember, now it's in a different spot. Okay, before the infinity was the answer for a y value, and we had a number here as our x was approaching a number. Now we're saying, what happens when the x goes to infinity and the answer will hopefully be a number? Okay, it's possible that that will actually be positive or negative infinity as well, but most of the time we're going to get a number here. So let's have our x's, like look at the x's, 3, 4, 5, 6, 7. They keep getting bigger. So x is getting bigger. Stay on your graph. Keep following your graph. Keep following your graph. Head towards infinity. Head towards infinity. What y value are we getting close to? We are getting close to negative 4. Okay. Let's try one more. what about the limit as x approaches negative infinity of the function f of x? Okay, once again, negative infinity would be way, 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 way to the left here, right? We want to move far, far to the left. We have -1, -2, -3, -4. So when we are trying to find our answer, we are going to go onto the graph, right? Onto the graph of the function, and we're heading towards x. X's are heading towards negative infinity. That's a better way to say it. X's are heading towards negative infinity. What y value are we getting closer to? And it seems like we're getting closer and closer to y equals 0. So that would be the answer. Getting closer and closer to y equals 0. All right. So that is the lesson today. Just a quick recap, we could get positive or negative infinity. So you see these two examples. Our x is going towards a number, but our function is heading towards negative infinity or positive infinity. Then we could also ask what happens if the x goes towards infinity or negative infinity. So instead of looking at the x going towards a number, the x is going towards infinity or negative infinity. And the answer, most of the time, we're hoping that we're going to get a number as the answer. Okay? It is definitely possible to get positive or negative infinity for the limit of f of x as x approaches positive or negative infinity. And we will see that a lot, but you don't see that in this example here because there's horizontal asymptotes. Okay, so sometimes, let's see. If you look at this last page, just quickly, for problem number 1, if you took the limit of f of x as x approaches infinity, you would get, for this one, you would get 0, right? It's going down towards 0. Actually means there's a horizontal asymptote there. This one here would be an example of if you take the limit of f of x as x approaches infinity, okay, and you start following it, this function goes up and up and up, and it keeps getting larger and larger. As your x's get larger, the y's keep getting larger. So in this case, you could say that it was heading towards infinity. All right. Thank you for watching. Good luck on your Khan Academy assignments, and let me know if you have any questions.